NASA solar probe enters sun's atmosphere, makes closest pass ever, achieving a feat that eluded even Icarus. NASA's Parker solar probe flew close enough to touch the sun on Christmas Eve, emerging unscathed on the other side, breaking its previous record by passing just 3.8 million miles above the sun's surface. This fearless explorer dared to venture where even the gods have feared to tread. The Parker solar probe passed through the sun's outer atmosphere at a staggering speed of 430,000 miles per hour, 692,000 kilometers per hour, a velocity necessary to avoid being incinerated. Even with its advanced heat shielding, pausing to observe or record video could have proven disastrous. Despite its brief encounter with the sun's intense heat, the probe managed to collect a wealth of valuable data. These measurements have the potential to revolutionize our understanding of solar physics, as many mysteries about our local star's behavior remain unsolved. Flying this close to the sun is a historic moment in humanity's first mission to a star, said Nikki Fox, head of NASA's Science Mission Directorate, in a press release from the Goddard Space Flight Center. By studying the sun up close, we can better understand its impacts throughout our solar system, including on the technology we use daily on Earth and in space. This knowledge also aids in our search for habitable worlds beyond our home planet, boldly going where no probe has gone before. To reach its destination, the Parker solar probe traversed 90 million miles of space. Launched in 2018, the probe made multiple flybys of Venus, using the planet's gravity to gradually steer closer to the sun. Its final Venus flyby on November 6th of this year positioned it in an optimal orbit for its historic close encounter. The probe's carbon foam shield, capable of withstanding temperatures up to 2,600 degrees Fahrenheit, ensures its instruments remain at room temperature. During its flybys, the shield is expected to heat up to only 1,800 degrees Fahrenheit, ensuring the probe's functionality for years to come. It's monumental to get a spacecraft this close to the sun, said John Wurzburger, a Parker Solar Probe mission systems engineer from the Johns Hopkins Applied Physics Laboratory, APL. This is a challenge the space science community has wanted to tackle since 1958, and decades of technological advancements have made it possible. Unlocking the sun's secrets. During its passes through the sun's scorching corona, the Parker Solar Probe aims to uncover how this region heats up so dramatically. It will also trace the origins of the solar wind, the constant flow of superheated particles escaping the sun, and investigate how energetic particles are accelerated to nearly half the speed of light. Even during its earlier, less close passes, the probe delivered surprising findings. For instance, it revealed that the corona is not smooth but instead wrinkled with spikes and valleys. Near the sun's visible surface, known as the photosphere, the probe identified the source of zigzag-like structures in the solar wind, called switchbacks. The data is so important for the science community because it provides a new vantage point, said heliophysicist Kelly Korek, a program scientist at NASA headquarters. By directly observing the solar atmosphere, the Parker Solar Probe has transformed our understanding of the sun. The probe has also made discoveries about the inner solar system. It observed how coronal mass ejections sweep up dust as they travel and gathered data on the energetic particles steadily emitted by the sun. Flybys near Venus captured the planet's natural radio emissions and photographed its orbital dust ring. Future missions and discoveries. The Parker Solar Probe is scheduled to pass close to the sun twice more in the first half of the new year, on March 22nd and June 19th. Analysis of the data collected during the Christmas Eve flyby is set to begin soon, with expectations of revealing new surprises. This mission continues to push the boundaries of space exploration, bringing us closer to understanding the sun and its profound influence on our solar system.